Hello friends, we have reached to lecture 5 on differential equations, and just in 10 minutes you will know about linearity of ordinary differential equations. And for that you need to remember only 5 points. Yes, only 5 points, and you will master the concept of linearity in case of ordinary differential equations. One more thing that I will tell you in this lecture is an interesting fact about linearity concept in case of ordinary differential equations. So let us start without any delay. First, let us see that what you will find in this lecture. Okay, you will find a platform for classification of ordinary differential equations, definitions of linear and non-linear ordinary differential equations, examples to make the concept clear, and an interesting fact about linearity concept, and finally some references. Okay, so first is classification. Linearity provides a platform to classify ordinary differential equations. And based upon linearity concept, ordinary differential equations are classified into two categories: linear ordinary differential equations and non-linear ordinary differential equations. Now we'll learn these two one by one. First is linear ordinary differential equation. So first is formal definition of these linear ordinary differential equation. As per S.L. Ross, a linear ordinary differential equation of order n in the dependent variable y, independent variable x will be equation of this form: a naught x dn y by dxn plus a1 x dn minus 1 y by dxn minus 1 up to an x y equal to b of x, where all these a naught, a1 up to an, and also this b on the right side, all these are functions of x, right? And this there is condition on this a naught x, because you are saying that this is nth order differential equation. So there should be condition on this a naught, and that condition is that this a naught should not be identically 0. Okay, so for linearity, why these equations are linear, there are 5 points that you need to remember that are very important to check any ordinary differential equation, to check its linearity. And what are those 5 points? The first point is dependent variable and all its derivatives, they should be of degree 1. There should be no product of dependent variable with its derivatives. There should be no products of different order derivatives with each other. There should be no transcendental function of dependent variable, and there should be no transcendental function of derivatives, right? There is b of x and all these coefficient functions, but there is no restrictions on these functions of independent variable x. They can be algebraic as well as transcendental, right? So these are those 5 important points that you need to remember. And if you know about these 5 points, then you will master definitely the linearity concept in case of ordinary differential equations. Now we'll give the definition of nonlinear ordinary differential equations. It's very simple. The differential equation, ordinary differential equation that is not linear, will be nonlinear ordinary differential equation. Fine. And now to make this concept more clear, we'll take some examples. First example, see, we need to check all the 5 conditions one by one, right? The first condition was that the degree of dependent variable and all its derivative should be 1. That is satisfied. Second was y should not be multiplied with its derivative, satisfied. Third, derivatives should not be multiplied with each other, also satisfied. Fourth, no transcendental function of dependent variable y, satisfied. Fifth, there should be no transcendental function of derivatives, also satisfied. So this example, this differential equation is a linear ordinary differential equation. Okay. Now we'll come to example 2. Now in this case you can see, yes, of course there is x square, but we don't bother about this independent variable. We just check the dependent variable and its derivatives, right? So if we check as an example 1 all the 5 conditions, then we can see that all the 5 conditions will be satisfied in this case. There will be no problem. So this is an example of a linear ordinary differential equation. Fine. Now come to next example. In this example, now we can see dy by dx. So y is dependent, x is independent, right? So there is y squared. So this dependent variable has degree 2. So first condition is not satisfied. It means that this is a non-linear ordinary differential equation. Yes. Now we'll come to next example. In this example, again because derivative is of y with respect to x, so y is dependent, x is independent, right? Even if there is x square, but we don't bother about it. But there is problem of this too. Yes, here this second order derivative has degree 2. Fine. So our first condition of linearity is not satisfied. It means that this is a non-linear ordinary differential equation. Fine. Now we'll come to next example. In this example, see what is the problem? Degree of y dependent variable. Y is 1, derivative is 1, but y is multiplied with its derivatives. It means that second condition is not satisfied with linearity. It means this is a non-linear ordinary differential equation. Fine. Now come to next example number 6. Now I think this is clear to you that y is dependent variable, x is independent variable. Fine. Y and all its derivatives has degree 1 first satisfied. Y is not multiplied with its derivative second satisfied. But derivatives y dash and y double dash, these two are multiplied with each other. It means third condition of linearity is not satisfied here. So this is a non-linear ordinary differential equation. Okay, fine. Next example number 7. In this example, y is dependent, x is independent, and sin y is there. It means transcendental function of y is dependent variable is there. So the fourth condition of linearity is not satisfied in this differential equation. So this is a non-linear ordinary differential equation. Now in the next example, y is dependent, x is independent. No problem for first condition, second condition, third condition, no problem. Fourth, there is tangential function sine, but this is of independent variable, right? So there is no problem because of this. Fine. So it means all the 5 conditions of linearity is satisfied. So this is an example of linear ordinary differential equation. Got it? Okay. Now come to next example. In this example, y is dependent, x is independent, and I think you can see now clearly that e raised to y is there. Y is dependent variable, so this is transcendental function of y dependent variable. It means fourth condition of linearity is not satisfied. So this is a non-linear ordinary differential equation. Fine. Now come to next example number 10. In this example, y is dependent, x is independent. We can see a transcendental function, but that is of independent variable, so no problem. I think all the 5 conditions satisfied. There is no problem in this case. So this is a linear ordinary differential equation. Fine. Now come to next example 11. In this case, y dependent. Independent variable is not given, we can assume as x, right? This is your choice, and there is no problem, but there is cos of y dash, right? And y dash is the derivative, so this is your transcendental function of derivative. Fine. So fifth condition linearity is not satisfied in this case, so this is a non-linear ordinary differential equation. Fine. So now I think the concept is clear to you by so many examples. And now I will tell you about an interesting fact about linearity concept in case of ordinary differential equation. And that is, there is no role of independent variable and the order in deciding the linearity. It's only the degree of dependent variable, its derivatives, their products, and the form of dependent variable and its derivatives that has all the rights to decide the linearity of ordinary differential equations, right? and now some references. So I'm sure that you would have enjoyed and learned something concrete from the lecture. Thank you so much for listening. Stay home, stay safe, stay happy. सर्व हिताय च सबका भला हो.